In this video, I'm going to explain in detail the power requirements and power consumption rates for our ATM machines. We're sometimes asked to provide an estimate of power consumption so that a location can factor the energy costs of operating an ATM. Let me explain how we calculate these values. All of our ATMs require 120 volts of AC power, using a grounded outlet and a standard 3-prong power cord. They are not hardwired, nor do they require conduit as part of the installation. Sometimes a location or facilities planner will ask what size electrical circuit the ATM will require. Commercial circuits are typically 20 amp, which is more than enough. 150 watts divided by 120 volts is only 1.25 amps. If the ATM will be installed on an electrical circuit that is shared with coolers, heaters, or anything else that potentially draws a lot of power, consider using a battery backup or UPS to ensure that the ATM is kept at a stable voltage. If the ATM runs with low input voltage, it can cause serious problems. The ATM at idle, which means powered on and waiting for a customer, will draw approximately 25 watts. So, if the ATM is powered on 24 hours a day, using an electricity cost of 20 cents per kilowatt hour, that equates to 12 cents per day or $43 per year. Note that in most cases, the ATM at idle will represent the majority of electrical usage. During a transaction, the ATM will draw between 145 and 155 watts during the dispense and printing cycle of the transaction, dependent on the model. For example, a G2500 with a 1000 note dispenser will be closer to 145 watts, and a GT5000 through-the-wall machine with a presenter dispenser will draw closer to 155 watts. Using a sample transaction of $100 withdrawal with a printed receipt, the average time for dispense and printing between models will be approximately 10 seconds. This means for each transaction, the ATM will draw an average of 150 watts of power for 10 seconds. The rest of the time, it's drawing 25 watts. If the machine does 40 transactions per day, that's 10 seconds times 40, 400 seconds, or 6.6 minutes. 6.6 minutes each day at 145 watts, again, assuming 20 cents per kilowatt hour, will equal $1.17 per year. So an ATM that does 40 transactions per day, operating 24 hours a day, will cost just over $44 per year. You can adjust the amount of transactions to better approximate your power consumption. I hope this video has been helpful. If you have any questions, please contact Genmega support.